Hey, this is Nick from mycodeteacher.com, and in this tutorial, we're going to be exploring the new MapKit framework provided in iPhone OS 3.0. We're going to learn how to embed Google Maps into our application, change the type of map, zoom in on the user location, drop annotations on the map in the form of a pin dropping from the sky, as well as learn how to use reverse geocoding so that when we double tap anywhere on the map, it'll tell us exactly the exact address of that point that we double tapped on. So, a lot of things to cover, might be a little long. Start by opening up Xcode and creating a file, new project. It'll be a view-based application, and you're welcome to call it and save it wherever you want, whatever you want. I'm going to save mine as MapKit. Very simple. I'll save it to the desktop. Just going to rearrange things around here, resize my window, make it bigger, and resize the editor. And I'll open up some folders here, classes, resources, and frameworks. First thing we're going to do is add the MapKit framework. Get this out of the way so we don't run into any errors. So we're going to right click on any framework, in this case UIKit framework, and reveal in Finder. This will open up the folder where all your frameworks are kept. So what we need is the MapKit framework, found right here. You just take that and drag it into your frameworks folder in Xcode, and click add with these settings. They should be default. If they're not, change them to be so. And also, in case we need it later, we're also going to drag in core location framework. We are working with locations, so it might come in handy later. Now we're going to close the frameworks folder. At this point, we have to add the framework to the files we'll be working in. In our case, it's going to be MapKit viewcontroller.h. So we're under this import UIKit line. We're going to do import MapKit /mapkit.h. This will import all the header files associated with MapKit that we'll be using, and then Apple S to save your project. Now that we've done that, we can go ahead and create one IB outlet of type MKMapView. That stands for MapKit MapView. It's hard to say, and we'll call it MyMapView. That'll be our outlet. Again, as in all my tutorials, this is not a tutorial on Interface Builder, so if you don't know how to use it, go read your iPhone Beginner Handbook provided with your subscription to My Code Teacher, or watch other tutorials which explain how to use Interface Builder. So now we're going to open our MapKit viewcontroller.nib file, and we have our view here. This is what we were working in, not the main window. And you got to go to Tools Library if you don't see your library window. If you do, just go to Objects and find the map view. It looks like this. You're just going to take it and drag it out into your view. It'll size itself accordingly. You can take a look in the Attributes tab here of the Inspector, Tools Inspector if you don't see it. In the Attributes tab, you can change the type of map. We'll be doing this from within the application later. One thing I'm going to do is I'm going to check the box shows user location, so it'll put a little blue dot where the user's location is. Now we'll save and click into this here, Files Owner. If you go to the Attributes tab, you'll note that Files Owner is the MapKit view controller, which is what we put our IB outlet into. So we can go to Connections and connect the map view to the map view and save. Make sure you save or it might not work. Once that's done, we can go back into Xcode, and already we can just build our project. You can go to build Apple B like I did, or build, and once we see succeeded, no errors, click build and run. There shouldn't be errors, we didn't really do anything. Just make sure you import MapKit or this won't work. Now you see when our app runs, we have a map. And there we go, there's the blue circle that shows our location. Now I'm actually in New York, but the blue dot is showing itself in California. In the simulator, you don't actually have the MapKit functionality, the GPS, that can detect where you are. So it always puts the user location at the Apple headquarters in Cupertino, California. So don't be surprised when you run your program and it doesn't show where you actually are. It'll always be at the Cupertino headquarters because the simulator doesn't actually know where you are. You see you can move around by clicking and dragging. You can double click to zoom in, or you can put two fingers on the simulator by holding the Alt key and clicking and dragging out. You can zoom all the way in. So we'll go like to our location. You could double click or pinch in and out by holding the Alt key to simulate two finger motions. And you could go way down all the way into like street level and look at all the streets and get very close. So there you go. Now you have Google Maps embedded in your application. Let's see what we could do with it. Do some cool things. So the first thing we're going to do is we're going to go back into our interface builder. We're in our library objects tab, we're going to drag out a toolbar, a UI toolbar. We're going to put it at the bottom. I'm then going to click on this button and delete it, so we just have a blank toolbar. Then go to the Attributes tab. Let's make it look a little cooler. We'll make it black translucent, so it'll be like see-through, black and see-through. Now that we have that, we're going to take a segmented controller, UI segmented controller, and drag it into here. There is a tutorial on My Code Teacher about using segmented controllers. I'm not really going to go over it too much here. You can watch that tutorial to see really everything you got to know about UI segmented controllers. Once I have that, I'm going to click on it so it brings up the segmented controller attributes. I'm just going to change the tint by clicking tint. And sorry, my window's over here. Clicking tint, I'm just going to make it like a gray color that'll look it'll look nice with the black bar. And then I'm going to take some flexible space, this little double-ended thing, and I'm going to put it on the left side to put the segmented controller all the way over here. Segmented controllers over here, we're just going to create 3 tabs instead of 2. So I'm going to click on the segmented controller. Here we go. I'm going to change segments to 3. Then I'm going to edit the titles of them. The first one's going to be Map. Second one's going to be Sat for satellite. Third one's going to be Hybrid for map and satellite together. I can then click these little buttons here and resize it to be about that big. And we'll have map selected as the default. If you click on the map view, you'll note that these are the 3 types of map. That's what we're going to be changing with the segmented controller, the types of map. Now that that's laid out, let's do some connections with it. We have to do an IB outlet UI segmented controller. Segmented controller. We'll call it seg control. You can call it map type control, whatever you want. I'm calling it seg control. Then I'm also going to create an IB action called seg change. Again, if you don't know IB actions, go read the handbook, watch other tutorials that explain it. Save that file so that when we go into Interface Builder, our new connections are available. When we click Files Owner, go into Connections, we can have connect seg control to the segmented controller and seg changed to the segmented controller, selecting the value changed. So now if we save that and go back into Interface Builder, we can take our method and paste it into the viewController.m. Just like that. And now anytime the seg controller changes, it'll call this method seg change. Let's get some of this commented out text away and just work in here. So what are we going to do in here? We're going to change the map type. So what we're going to do, if seg control dot selected segment index equals 0, which is just plain map, which is the default, but we have to account for it at some point not being the default and check for it. We're going to call this method my map view set map type, and it'll be mk map type standard. Is just a plain map. I'm then going to copy and paste this whole block here, paste it below, and do else if the selected segment index is equal to 1. So if we're on the second tab, we're going to do mk map type satellite. And then underneath that, we're just going to do else. So if it's anything else, and the only thing else it could be is the third segment, which is going to be my map view set map type mk map type hybrid. Okay, so now we have those set. We can save Applebee, build our project to check for errors. Succeeded, so no errors. And let's run our project. See what we just did there. Okay, now see we have the plain old map like we always did. Shows our user location. When we change this to satellite, the map changes to a satellite map instead. Let me zoom in here a little bit so you can see. There's no roads or anything, just a satellite image of the country. If you're not in the United States, then not your country, but a country. And if you go to hybrid, then you see satellite and roads. So now you have all 3 map types available for the user to change between. Go back to map, satellite, hybrid. So there's your 3 types. Okay, the next thing we want to do is we want to zoom in on the user's location. So what we're going to do is we're going to go back to our viewController.h, and we're going to create a new action. It'll be IB action. We'll say hit zoom. Save that and go back into the MapKit view controller. What I'm going to do is I'm going to take a bar button item, a UI bar button item, and drag it onto the other side of this flexible arrow. It'll put a button over here, which I'll call zoom in. So now I have a button that says zoom in. I'm going to then go to Files Owner and connect Zoom in to that button that says Zoom in, or hit Zoom, and save. So now we have this method here, hit Zoom, which we could take and paste into our, put it above, into our .m file. And what we want to do when we hit the zoom button is we want it to zoom way into the user's location, really, really close. So what we're going to be using is the method MapView set region. To use set region, we have to create a region, and to use a region, we have to create a span. I can show you this in the documentation, but I'm just going to go through it right here. It's called a MK coordinate span, and we'll call it span. You don't need to do the asterisk. This is kind of like an integer. You don't need a pointer to it. It's not an object. It's a span. Kind of like a CG point, we're going to do MK coordinate span make, just like we do CG point make if you've seen any tutorials that use core graphic points. And then we got to pass in latitude delta and longitude delta. So change the latitude we want, change the distance we want, and the longitude distance we want. So we're going to zoom in really close. So we're going to do something like 0.01, like it's pretty much as close as you can get, and 0.5 are going to be our span. So it's going to be 0.01 degrees across, latitude-wise, and 0.5 degrees longitude-wise is going to be the span of our region. Now we have to create an MK coordinate region. We'll call it region. And we're going to do MK coordinate region make. We have to pass in a center coordinate. What we're going to do is pass in the user location. Which if you had looked in the documentation, you'll see this. It's my map view. So NEUI map view dot user location. But we're not passing in the user location. We're passing in the location of the user's location, which is the CL coordinate location 2D. Dot coordinate. That's the CL location coordinate 2D. So this is the whole thing here. MapView.userLocation.location.coordinate. That's what you have to pass in, because I was looking for a CL coordinate 2D, and that's what we gave it now in the coordinate of the location. You could follow the tree through the documentation of starting at MapView, going to user location, then coordinate to find what you need. Now we have to pass in a span that we just created. We'll pass in span, and now we have a region. So my map view, set region, and we'll pass in region as our parameter. This should zoom into the user's location once it's found. So already we could build our code, make sure there's no errors. We do have some errors here. Let's see. Unused variable span. Okay, I forgot to put a semicolon after MK coordinate span make. I add that and build again. You see, everyone makes simple mistakes sometimes. And now I'll build and run the project. We have our new button zoom in. Once the user location is detected, I'll change the hybrid method here. I like the way it looks. Click zoom in. We zoom way in, okay, just like that. But you see, it just kind of like flashed in. Maybe we want it animated, a nice little zoom. Because I was just kind of like, okay, bam. We want it to be a nice smooth animation. So set region has another method, set region animated. And if you pass in yes to the animated parameter, which you can go look at the documentation, you'll see set region and set region animated. Now we can run the project with that new animated yes after region. And when we click zoom in, it'll go way like that. See a nice cool zoom in. And now we're really close to the user's location. Of course, it can be zoomed in closer. You're welcome to change the span so that it's, but this is the zoom in that I wanted for this tutorial. So that's zooming in. And the next thing we're going to learn how to do is drop pins. That is a little more complex than what we've been doing so far, but I'll walk you through it. We'll get through it. So we're going to create an annotation now. Let's go take a look on our developer documentation. This is pretty complex. Let's take a look at MK annotation view. You can just type in this search bar MK, start typing annotation. It should pop up over here. MK annotation. Okay, now MK annotation is a protocol. It's not really something you could just call. You have to create a class that conforms to this protocol. Kind of like when you are using delegate methods, you declare the delegate in the .h, and then put the delegate methods in the .m, and you conform to the delegate protocol. So we're going to create a class that conforms to the MK annotation protocol, and we can then call that class. So let's go into our Xcode project, create file, new file. It'll be an Objective-C class in the Cocoa Touch classes, subclass of NSObject. We're starting from root. We're starting from NSObject. We'll call it my annotation. We create it .m, make sure you create the .h also. And the target, we're going to put it in MapKit. It'll add these files right here, myAnnotation.h and .m. So we have to do, start in the .h, first things first, import the MapKit header file just like you did in the view controller. Once you've done that, take a look here. There are three things we're going to put in it: coordinate, title, and subtitle. Coordinates, CL location coordinate 2D, and these are each NS strings. Title and subtitle are NS strings. So we're going to do that like this: CL location coordinate 2D coordinate, we'll call it coordinate. Now we have our coordinate. NS string title and NS string subtitle. Now we have the three things that we're allowed to put in the MK annotation protocol file. We have them in there now: title, subtitle, coordinate. Now we have to declare them as properties so we can access them from other classes. Go read your developer handbook if you don't understand what I'm doing here with properties. It's got a really good explanation of properties. So we're going to say non-atomic retain. Oh, wait, hold on 1 second. Sorry, non-atomic read only. You have to declare the property. So non-atomic read only CL location coordinate 2D coordinate. Our next property is going to be non-atomic retain NS string title. So we're just creating a class that conforms to the protocol laid out for us. Just word for word what it says to do. NS string subtitle. So we've declared our objects and our coordinate. We've declared our properties. Save that and go into the .m, where we're going to have to synthesize our properties. At synthesize, you always have to synthesize anything you declare as a property. So coordinate at synthesize title, and I'll just do this subtitle, so you can put commas. You don't have to keep writing synthesize every time. Now we have to implement our init methods. What we're going to do here, we're going to pass in, we can type in INI and hit escape to bring up our autocompleter, whatever you want to call it, and put the standard init definition. This is the standard init for any class. We're going to change it a little bit to be init with coordinate, and we're going to pass in CL location coordinate 2D. We'll pass in coord. So now we can initialize the class not just by calling init and then setting the coordinate, but just calling init with coordinate and passing in a coordinate, which will then say here coordinate equals coord. Sorry if this is a little confusing. You kind of have to have a grasp of classes and how Objective-C works to understand what I'm doing here. Again, go read your handbook, other tutorials, plenty of ways you can learn all this if you don't get what I'm doing. The primary focus of this tutorial is MapKit, not what I'm doing here. I just have to do this to teach you about annotations. So we're going to initialize our title and our subtitle. We're not even going to be using subtitles. It's just good to put the things in the protocol in the class. And now, of course, let's do our deallocations. DEAL escape, and type in our deallocation definition, or just copy down what you see here. And we will release our title and our subtitle because we allocated them, so we have to release them at the end. It's good practice memory management. Now we've created our MyAnnotation view classes. Let's go back into our .h, close the documentation here, and we're going to import MyAnnotation.h in our map view controller.h. We're also going to do this at class MyAnnotation. This is just telling these files, it's like a guarantee to these files that MyAnnotation exists, so it helps it manage the files. Just put it at class MyAnnotation in the .h. Once you've done that, we're gonna we're just gonna create one thing in here. We're gonna create an int, and we'll call it pin number. This will keep track of the number of pins we've dropped on the map, and you'll see how I'm going to use that in a second. We're also going to create a new IB action. IB action. And it'll be, how about drop pin? Drop pin. And save. And now we're going to go into our interface builder, and we're going to create a new toolbar at the top. Just drag out here just like I did before. See, it remembers that I want it translucent. It does it automatically. And this button here will say drop pin. And then we're going to connect in the file's owner, connect drop pin to the drop pin button, and save. So now we have a new toolbar top with the drop pin button. We'll take this method, pop it in the .m, and now we have it there. Drop pin. So what do we want to do in drop pin? What we're going to do is we're going to get a random x, we're going to get a random y, we're going to create a point, and we're going to just drop a pin down at that point. Completely random. We're not dropping a point at any specific point. I'm just teaching you how to drop pins on the map. Might as well do it at any random point. So what we're going to do here, first, what we want to do is in the method awake from nib, which you can create right here, hyphen void awake from nib. This will be called when the application launches, when the application awakes. We'll set that pin number variable I said. Set it equal to 1. We'll set it equal to 1, and you'll see what I do with that in a second. So now in drop pin, there's a couple things we're going to have to do. We're going to have to create a random x and a random y. Let's do that first. Int x equals arc4 random. This generates any random number. And the reason we use arc4 random instead of just random is random will generate the same random number every time, where arc4 random generates a different random number every single time. And then what we want to do is only have values between 0 and 320. So do %320. Brief explanation for the people that are in that know a lot of math knowledge. It's modular. We're using mod. So whatever number we get, we're dividing it by 320 and taking the remainder. People who don't know what that means, all you need to know is this will return a number between 0 and 320. So we're going to do that, and that'll actually return a float. So we're going to have to do this in the beginning to take it as an int. So parentheses int end parentheses, and put a semicolon at the end. If you don't understand what that's doing, just know it's giving us any random x value between 0 and 320. So now let's do the same for y. Random percent. And in the y, we're going to do 480. Okay, so we've got any x value between 320, which is the width of the iPhone, and any y value between 480, which is the height of the iPhone. So now we're going to create a CG point, like I mentioned before. We'll call it point equals CG point make x and y. X and y. Now we have to take that point and convert it to a coordinate in the map. Now the map view has a view for this, so we'll declare a CL location coordinate 2D called coord, and it'll be equal to my map view convert point, pass in our CG point to coordinate from view, pass in any view, we'll pass in self.view because that's where the map view is located. So this will convert our CG point to a coordinate, which will be stored in this CL location coordinate 2D coord. Now we have to use our my annotation. So my annotation, we're declaring an object of our my annotation as annotation equals my annotation allocate init. You see we have init with coordinate, which is the method we created. We can pass it coord. This will return us back an allocated and initialized annotation based on the file we created before. We can now set that title because we declared title as a property. That title equals ns string with format. This allows us to pass in variables into a string. You may have seen it before. And let's open up a string. We'll say pin %i, comma, pin number. %i is a placeholder for an integer in the string. So then we do comma after the string and pass in an integer, in our case pin number, and then it'll replace %i with the value of pin number. So that's what string with format does, if you didn't know that. And now we're going to increase the number of pin number. What this is doing, plus plus, is saying pin number equals pin number plus 1. You're welcome to do that too. Just pin number plus 1, but it's just good practice to just do pin number plus plus. It's quicker, more efficient. And once we do that, we're going to call my map view add annotation, and that'll add an annotation to our map, but not how we want it. We want to drop a pin. So we have to do one more thing. We have to use a delegate method of the map view. So let's go into our developer documentation. Type in mk map view delegate, and you see there's this method here, view for annotation. So we're going to take this map view for annotation, and we're going to copy it right into our .m file, right under our drop pin method. And then make sure in the .h you declare this file as a mk map view delegate. I've gone over this before, other tutorials going over why you need to declare the h file as a delegate, but just know that anytime we call add annotation, it'll call this method view for annotation, where we declare the view of the annotation. So now we're going to be using a new class provided by Apple. It's in the documentation, mk pin annotation view. It's right here. It's the pin annotation that you could drop on the map. So we're going to call mk pin annotation view, call it an view, like annotation view, equals mk pin annotation view allocate init with annotation, pass in the annotation, which is a parameter of this method, which has to be something that conforms to the mk annotation protocol, which our class does that we created. And reuse identifier, you can pass in any string to this. I'll just call it annotation1. You can pass in anything, and then if you ever want to use the same annotation again, you can refer to it by this identifier. We're not going to be dealing with that in this. Okay, so now that you've done that, we can also set some properties of the mk pin annotation view, such as animates drop. This is if it animates the drop from the sky or not. We'll say yes. And view can show callout. So should it show the callout, which contains title, which you can read about that in the mk annotation documentation. And then we're also going to set the color, and view.pin color equals, pass in, they provide us with some things we can use. There's mk pin annotation color red, green, and purple. We'll use, how about purple? mk pin annotation color purple. And then we return and view. Now, I know we just did a lot of stuff, and it seems really complex for adding a pin, but these are the steps you have to take to add a pin annotation to your view. I'm going to build and make sure there's no errors. I have one warning, which is that the my annotation does not implement the mk annotation protocol. That would be because, one second, we didn't in the myAnnotation.h state that this is protocol mk annotation, just like we declare in here that this is a mk map view delegate protocol. We have to declare in this .h that this is a mk annotation protocol. Sorry about that. Let's build, and you see succeeded, so we can build and run. And after all that work, we can, let's say, use our new zoom in button to zoom in on the user location, change the map to hybrid, and then just hit drop pin. And you see you're dropping pins. Now, unfortunately, you see they're red and they're not dropping from the sky. I know why that is. If you just bear with my mistakes for 1 second, I'm really sorry. We actually didn't declare my map views delegate as self. So once we call add annotation, it doesn't know what file to call to find this delegate method. So we have to set the my map views delegate to self. Now that that's set, let's build again and zoom into the user's location. And now when we drop a pin, it's still not being called. Sorry. Switch over to your interface builder. I forgot to do this stuff. And click on the map view and drag the delegate to files owner. So map views delegate to files owner. And now when you run, finally, again, sorry for all the mistakes. When you drop a pin, it'll drop down and be purple. So we'll zoom in, and you can click drop pin, and it'll drop pins all over. You can keep clicking, and when you click any pin, it'll tell you what number pin it was, because of that pin number variable that we kept increasing every time we added an annotation. So after all that, we can drop pins. You'll see it also changes the user location annotation, which was a blue circle, to be purple. If you want, you're welcome to go like this. If annotation equals my map view dot user location, which is an annotation. Then we can, I don't know, set the pin color to MK pin annotation color, we'll say like green for the user's location, else be purple. And now when we run, you'll see the user's location pin is green and any other pin we drop is purple. You notice the pins are always dropped within the rectangle of the screen because we grabbed any X between here and any Y between here and then converted it to a point based on whatever's showing in the map at the current time. So that's what we've done so far. A lot of stuff. The last thing we're going to do is reverse geocoding. This is also pretty intense. Really cool though. Let's get started right away. First thing you want to take note of is that a map view swallows touches. And what I mean by that is when we double click on a map view, the map view is swallowing up that touch, that double tap, and using it for its zoom in action. So if we want to detect a double touch in our view controller.m, if we want to detect when the user's double touching, we're not going to be able to with the map view interaction enabled because the map view is literally like taking our touch, using it for itself, and not letting any other files see that touch. So in order to use our double touch to use reverse geocoding and what we want to do, we're going to have to disable the interaction of the map when we want to use the reverse geocoder. So what we'll do in the .h is create a new IB outlet, UI switch. We'll just call it, no, not switch, we'll call it geo switch. Save, and we're going to go into interface builder, and in that top toolbar where we have room, we're going to drag in a switch. Where are you? Switch. Oh, right here, sorry. Okay, so here's a switch, and then we'll put some flexible space, double arrow, in between them, and we'll set it to, if you click on it, we'll set it to off. And we'll also just for our own pleasure, drag in a label, reverse geocoder, colon, set the text to white, Apple T to bring up the font, and like set it to, I don't know, like Arial bold, Arial black. We'll set it to Arial bold and just decrease the font size a bit and put it over here. So now we have this little label that says reverse geocoder colon with a switch, which we will then click Files Owner and go to Connections and connect Geo Switch to the switch. Let's also create a method, IB action switch changed. It's kind of like our segmented controller changed. I spelled the switch wrong. And we'll connect that switch changed to the switch also in value changed. We're going to take that switch changed method and put it into our .m. What we're going to say is if geoswitch is on, then my map view user interaction enabled will be no. So when we want to reverse geocode, when the switch is on, we cannot interact with the map. Else, so if that switch is off, my map view user interaction enabled equals yes. Little point of interest here, if you'll note, when after else I opened up curly brackets, but over here I didn't open up curly brackets. If there's only one line underneath a if or else statement, you don't have to use curly brackets. Here I chose not to use them, here I chose to use them. It doesn't make a difference. Really all it does is just here it saves one line of code, this line, because you don't need the curly brackets. But you could use them, you cannot use them, whatever. So I'll save and run the program. We didn't do anything except here you'll see we could double tap, click into the map, move it around. But if I enable the switch, I can no longer move around the map. I'm double clicking, it's not doing anything. I'm clicking and dragging, it's doing nothing. With the user interaction of the map disabled, I can then detect the touches in this class, which I will do by going like this, void touches began. You'll see it's auto completed. If it doesn't auto complete for you, just type this in. We'll create a new instance of touch. So many tutorials use touches. I'm not going to go over them. This is to show reverse geocoder. So if you don't know what I'm doing here, you'll have to go look it up. CG point location equals touch location in view self. So let's grab the CG point that we tap on in this view, in the map view, when the switch is on. And then we're going to do here, if touch.tapCount equals to 2. So if we double tap, then we're going to do something. What are we going to do? We're going to get the exact address of the place we double tapped on. So we're going to be using a new class here. We're going to be using MK reverse geocoder. Let's go into our .h and create an object of that. MK reverse geocoder, we'll call it geocoder. What a reverse geocoder does, it takes a point on a map and gives you the address of that point. I'll open up the documentation and keep that up just in case we need it. MK reverse geocoder. You'll see you can do init with coordinate. It'll start doing its stuff and then call a delegate method. Did fail with error or did find place mark, in which case it was successful, and will return you an MK place mark, which in turn has all the things you need to know about a location, the address, the thoroughfare, the country, postal code, anything you really want to know about that point. So now that we have an object of MK reverse geocoder declared, we can start using it in our touches began method. So let's do that by first creating a coordinate that we could pass into the reverse geocoder. CL location, coordinate 2D, coord. That's usually what I like to declare it as from before. And we'll say my map view, convert point, and we'll pass in that location, which I just created up here, the location that we double tapped on. And pass in self.view. You'll note that this is a method we already used that returns a coordinate from a point, in this case the location. And then what we're going to do is we're going to say geocoder equals MK reverse geocoder. We're going to allocate it and do init with coordinate coord, which we just created. Set the delegate, geocoder.delegate equals self, and then geocoder start. So it'll start reverse geocoding on that point, and then we'll start creating the delegate methods, which will be called shortly. One thing I want to point out first, what we should do here is we should check if the geocoder already exists. So we can do that like this. If geocoder, if it exists, this will return yes. If it doesn't, this will return no. And if it does, then geocoder release. Because if we double tap a second time, then we don't want to be creating a new, we don't want to allocate MK reverse geocoder again, because that'll eat up all the memory we have. So we want to first release it and then allocate it again. The first time this is ever called, obviously it doesn't exist, so it won't release it because of this if statement right here. Now that we've done that, let's create our file. Let's declare our file as not only an MK map view delegate, but an MK reverse geocoder delegate also. And take a look at this delegate file here, which was MK reverse geocoder delegate. And we'll take the did find place mark method, copy it, and paste it into our .m file right below our touches began. And right here you see we call it geocoder start. The geocoder will start, and once it actually finds a place mark, once it can actually successfully reverse geocode, it'll call this method, did find place mark, and then we could pretty much get all the information we want about a point. And what I'm going to do, I'm going to log it to the console so we can see that this is actually working. First, let me close my, bring up the MK place mark documentation, all these things we could use, and we're going to go like this. NS string address string equals NS string with format, which I already explained we can use placeholders. What we're going to do is use the placeholder for a string, which is %at. This is the placeholder for a string. So just watch what I'm going to do here. %at, comma, %at, %at. So what I did there, %at, comma, space, %at. So I have 5 placeholders for strings. Now what am I going to pass into those placeholders? First we'll put a comma, and just to keep everything on screen, I'm just going to hit the return key. Objective-C is not sensitive to line. You know, it stops a line when you put a semicolon. That's why you put a semicolon at the end of every line, because it doesn't know when you stop a line. Because I can go like this, and I can start typing that here. It's still part of this line all the way up here, because I didn't put a semicolon yet. But anyway, what am I going to pass into the first parameter? I'm going to pass in place mark, which is declared right here, an MK place mark. dot subthoroughfare. And if you take a look here, subthoroughfare is street level information for the place mark, which it says in the discussion is the street number. So I'm going to do a typical address, street number, street, comma, city, state, postal code. So that's what I'm going to do. So first is subthoroughfare. Then I want to pass in the street name, which will be, as you'll note up here, it is thoroughfare. I happen to know that. Thoroughfare is the street name. So next we're going to pass in placemark.thoroughfare. I'm going to put another comma and go to the next line. For the next one, right here, for this parameter, for this placeholder, I'm going to pass in the dot locality, which is the city. If you take a look in here again, you could read that locality is the city, comma, placemark dot administrative area, which is the state, comma, placemark dot postal code. So after all that, and then just end the bracket and comma. After all that, I've got 5 placeholders in this string in this format, which I'm passing in the street number, the street name, the city, the state, and the postal code. And you'll see that'll look just like an address once I print it to the console. So now I have to log that to the console with nslog. This is a method that logs whatever we pass in to the console. Do another placeholder, %at, comma, address string. So we're going to pass address string into our console, just like that. And that's really it. We're done coding for this tutorial. Let's just look at how this works, make sure we're successful. Let's build. I have some warnings. I'm sorry, I passed in self to location and view. This is a view controller, so it's self.view. A view controller in itself is not a view, it's just a view controller. We got to access .view to actually access the view. Let me build again. You'll see I have some more warnings here. Let's see what those are. Incomplete implementation. Oh, I see. I'm sorry. If you go back to MK reverse geocoder delegate, you'll note there's one other method, did fail with error. The delegate file would like this to be implemented, so let's, right here, paste that, did fail with error. You're welcome to read the error if you know how to do that, or just pop up a UI alert view that says, could not find place mark. I'm just going to leave it there just so it stops complaining. And now you see succeeded when I build. So what I'm going to do, I'm going to run the project, and I'm going to open up the console with this little GDB button, or going run console. And now let's get this nice and close here. What we're going to do, we're going to change to a hybrid style, and I'm going to zoom into the user's location. Now I'm going to zoom in real close to street level, to being able to see houses. You see very clear pictures from Google Maps, thank you. And what we can do, we can go into this little neighborhood over here, zoom way in, and let's pick like a good house. Like, let's just go like over to here, to Glen Cove Drive. We have this house here. So let's turn on reverse geocoding, which in actuality what it's doing is just disabling the user interaction of the map, so I can click and drag and nothing's happening. If I double click on this house here, look at this, we have an exact address. 10510 Glencoe, oh that's what it's called, see, Glencoe Drive, Cupertino, California, 95014. That is the exact address of this house. I'll double click on the house next to it. You'll see 10498 Glencoe Drive, exact. This one, it says 10474. Let's double click on it. And it seems to be not the address that's stated on Google Maps, which is fine. It's actually 20920. Maybe it's talking about the house across the street. 10481, that's probably what's going on here. Oh, there we go. If I double click on it, 10474. So you can tell it is working. Even Google Maps says 10474. Right here we have 10474 Glencoe Drive. We could turn off reverse geocoding and go somewhere else. Let's zoom out a bit, and just as proof, we were in Cupertino, as you can see. Let's zoom out even more. Zoom back to the initial user location. Let's turn on reverse geocoding and just make sure our cities are right. So let me click somewhere in San Jose. Double click, San Jose, California. Let me go Palo Alto, double click. Close, Menlo Park. So But yeah, it's right next. So if we zoomed in all the way to Palo Alto and clicked the house in Palo Alto, it would work. If we double click on somewhere in Campbell, you see Campbell, California. If it can't find it, if we didn't click exactly on a house, it'll pass in null as the street number and possibly street name. So you would account for that in your code. This was just general to teach you how to work. If we double click somewhere in Fremont, you see it works. Fremont, we clicked on this house on Thornton Avenue in Fremont, California, and it works anywhere. So that's how to use reverse geocoder, right? We learned a lot in this tutorial. I hope you found what you were looking for if you were looking for something, and if you're confused, watch the tutorial again, watch other tutorials that explain some of the things you were confused about. But that's how to use MapKit. I hope you enjoyed.